Good evening, all. Our today's discussion is on hopping methods, frequency hopping versus direct sequence spectrum techniques. In the previous session, we have discussed on the major techniques that is followed here, FSS, DSS, and so on. So, in this session, we are going to discuss on the uniqueness between frequency hopping and direct sequence. Frequency hopping systems uses a radio carrier that hops from frequency to frequency in a pattern known to both the transmitter and the receiver. This technology is easy to implement and it is resistant to noise also. The limited throughput is between 2 to 3 Mbps at 2.4 GHz. Direct sequence systems uses a carrier that remains fixed to a specific frequency band. The data signal is spread onto a much larger range of frequencies at a much lower power level using a specific encoding scheme. The throughput is higher than the frequency hopping method and it has a better range coverage, less resistance to noise, which is made by the redundancy. It transmits at least 10 fully redundant copies of the original signal at the same time so as not to lose any information. Right? 802.11a. This is a IEEE standard which uses OFDM technique, that is orthogonal frequency division multiplexing technique. This OFDM offers higher bandwidth than that of 802.11b, which employs DSS, direct sequence spread spectrum method. 802.11a MAC access control or media access control is same as 802.11b, which is operating in the range of 5 GHz. The major advantage of 802.11a is it uses ultra high spectrum efficiency. The operating range is 5 GHz, band is 300 MHz. More data can travel over smaller amount of bandwidth. The speed is about 54 Mbps. It is less interference to noise and fewer products using the frequency 2.4 GHz band shared by cordless phones, microwave ovens, Bluetooths and wireless LANs. The major drawback of 802.11a is it has some specific standards. Proper guidelines or regulations have to be followed so as to meet the standards and interoperability. The standard is not accepted worldwide and there is no interoperability certification available for 802.11a products, and also it is not compatible or interoperable with 802.11b. Even though the standard is common 802.11, the versions are different. The versions are not interoperable. Version 8.2.11a is not compatible with 802.11b. And legal issues are it is a license free spectrum in 5 GHz band and it is not available worldwide. Only within the predefined regions, this is unlicensed, and beyond the range it has to be paid for it. And marketing. Beyond land band bridging, there is limited interest for 5 GHz adoption. Many people do not prefer, or many domestic users or network providers do not like this version. There is less scope for this version because of the restrictions in the frequency usage or license. Next important disadvantage is cost. So beyond this 2.4 gigahertz, 40 percentage of cost will be levied, and the range is 5 gigahertz range will be approximately 50 percentage of 2.4 gigahertz. The power distribution is not uniform throughout. Once the range varies, the power also gets decreased. Power consumption, increased signal require more power. If the signal quality is better or the data rate is higher, then consumes more power. Whereas OFDM is less power efficient than direct sequence spectrum technique. The major applications of 802.11a is it can be used for establishing connection between buildings and video audio conferencing or streaming video and audio. All these is feasible with this technology 802.11a. It can be used for large file transfers such as drawings, faster web access and browsing, and video streaming, high worker density or high throughput scenarios, numerous PCs running graphics applications. So this is about the important information regarding 802.11 and its versions, the main application, the advantages and disadvantages. Thank you.